Hello and welcome to the webinar Private Access Protect Pro powered by Zscaler with Dennis Barbaros and Oliver Meyer from T-Systems and Nathan Howe from Zscaler. My name is Philipp von Schmeling from DVR GmbH, and today I am the technical support and will represent you in the Q&A session. Before I hand over to the moderator Dennis Barbaros, a few small technical notes. The webinar will be recorded, but don't worry, that doesn't apply to you. It's just a recording of the speaker's presentation and audio feed, which will be made available to you after the webinar, in case you want to watch it again. You may have a question during the webinar. If you look at your control panel, you will see that you can enter your question there. Please feel free to use this opportunity during the webinar. In the following question and answer session, your questions will be answered by the speakers. If you do not want to have your question answered publicly, please point this out in the question. In any case, the questioner remains anonymous for the rest of the audience, and we will come back to your question personally. Okay, and now it's my pleasure to introduce Dennis Barbaros and give over to the presentation.
Thanks a lot, Philip. So thanks a lot, everybody. Thanks for joining our webinar for the product Private Access Protect Pro powered by Zscaler, which is kind of new with the service rep within our Telekom Security portfolio. My name is Dennis Barbaros, and I'm a product and partner manager within Telekom Security for network security products, especially for responsible for the Zscaler products within the DT group. And I'm proud and happy that Nathan Howe and Oliver Meyer will take you through the product presentation. Nathan, I will pass over to you.
Thanks, Dennis, and thank you to T-Systems for having me today. It's a real pleasure and honor to be here presenting with you and Oliver. So as Dennis points out, my name is Nathan Howe, and my job at Zscaler is titled officially the Director of Transformation, which is a fancy way to say basically that I help customers and prospects and partners with their IT strategy. So it's really good to be here, and I really look forward to discussing this with everybody on the call. Oliver, over to you.
Thanks, Nathan. So my name is Oliver Meyer. I'm a security consultant inside the Telekom Security. I'm responsible for different vendors. One of these is Zscaler, so I'm here today to present you how we do a deployment for the product and what we offer afterwards. So Nathan, back to you.
Great, thanks, Oliver, and thank you again, everybody, for having me. So I wanted to start by asking you, the listener, why is it you actually have a job in information technology? And by this, I mean, really, what is it information technology does? And how do we really help? So I'll let that question sink in for a minute. And I think it's important to give that thought as we go ahead. Okay, that's long enough, but really what it's about, in information technology, if you look at it at its core, it's about connecting people, or providing people access to information. And we categorize the information a little bit differently. We call it users, and we have information hosted in apps. So what should be clear, though, is that for people to access this information, there needs to be a connection between these two. The user needs to be connected to where the information is, right? The user in the app must share that same network in order to be able to share information. And this was easy when everybody drove into the office, walked to the desk, plugged the computer into the network, and then got access to the locally hosted apps. But I think we can all agree today that that's not really the way things are working anymore. So let's consider this. What happens then when you have applications that are outside the bounds of your ecosystem and they're beyond your local network? How do you connect people to these applications? And that's exactly what I want to talk to you about today. So if we give some consideration to the way in which enterprises connect, I think the answer to the question of how we should probably do this needs to be addressed by looking at what we've done previously. And enterprises either had to connect networks, so trusted networks, or provide remote access services such as you see here. In both of these scenarios, the network interconnect and the remote access, the onus was really on was to implement controls by applying controls within the network flow. So in this diagram, we simply want to show when an enterprise builds that remote access service, it's quite a complex flow for traffic to get to the application it needs to get to. And what is important to realize, much like with any service that you want to connect to, especially in the world of TCP/IP, the nature is that you have that application exposed to the people who want to consume it. And that means for remote access services that it needs to be exposed to the internet. And this leaves your service exposed not only to those who you'd like to have access, but those who perhaps should not have access. So in this diagram, the risk has been something that we mitigated by implementing controls like DDoS or firewall, but the service is the VPN, and the controls are there to protect the VPN and the infrastructure around the VPN. So when someone does connect to a service from beyond the network bounds, you need to lock them into a path. So you can apply controls to them as is shown here. Doing this has been the normal way of working for a long time, and more importantly, it's actually quite complex to manage with different sets of controls implemented to protect the business at different points. So there needs to be a better way of working. And ultimately, that's where we come into the idea of how do you get beyond complexity, but also it should be clear that before the 2020 crisis, crises of 2020, not just COVID-19, but others, like the bushfires in Australia, that people must have access to applications from anywhere. And to get them connected to that trusted location, or where those applications are hosted in multiple places, means that a model like this just doesn't scale. And you probably have already started with a set of hardware and services that you once built to maintain access to your VPN and corporate assets. Most companies only estimate roughly between 20 to 30% of the workforce being remote at any one time, and have built their infrastructure accordingly. So we've all clearly exceeded that expectation today. So you'll need, no doubt, reconsider how things are being done and how this influx can change. So traditionally, as more users are added, you needed to add more hardware and more services to manage this again and again. The question here comes in, where do you stop? And because the pain will become stronger, not just because of the technology or the cost, but in these crisis times, there's a delivery of such hardware about 3 months and climbing as we wait to deliver this equipment. So how can you provide this service, the services needed for the enterprise? It should be clear by now that something really needs to change. And it has. This is where zero trust really comes in. Now, there's a lot of buzzwords around zero trust, and you may hear a lot of things named either ZTNA or ZTNA or SDP or zero trust network access. And while these are all somewhat accurate, I think it's important to simplify things. Zero trust really is about delivering the idea of least privilege. And by that, it means only connecting people to what they need and nothing more. And this is done by simply starting at a point of no trust or in zero trust, then building trust up from that point of zero between two entities through a set of assessments and controls. Then only after confirming and assessing the parties and building those controls will anything be allowed to connect or share information. At the end of this exchange, the trust is stripped away and only to be rebuilt at the next request. So it's never a permanent set of trust. So now how this works in the network path is this is how it works in the network path today. So going to a diagram to answer this question, enterprises either had to integrate their networks, as we've discussed before, but more importantly, you should consider that most of these services really are network related. And network connectivity has some challenges. So we see that people will need to access these services. These services need to be hosted somewhere that is exposed to that connectivity, again, via the network. And the problem is when you have a network that is and a gateway that is exposed, anyone can knock on that door. So once the user is validated in this solution, they're then logically connected to that network and thus have access to the entirety of what is in that network space, that trusted network. Just by looking at this diagram, it should be clear that the more people you need to add, the bigger the boxes you need to have, the more boxes you need to have, just like we demonstrated before. So we all agree this doesn't scale. But when your apps are spread across multiple locations, such as software as a service, platform as a service, how do you maintain a unified set of controls and a unified user experience? So really, of course, there needs to be a better way, and that's why I'm here today to talk to you about this. So let's start by talking about the three key criteria that not only set the foundation for connectivity, but also for control. In fact, there is a little secret here that I've been talking about from the very start of this presentation. And there's the 3 points I'm going to outline below. The user, who is the person that needs access. This is critical to understanding the access control. Without the notion of who, there should not be a connection, which again is critical to the zero trust model. So identifying the user who is requesting access is key. Doing this is as simple as using an identity managed within your enterprise's IDP or identity provider. And that's what most of you have. Once a user is authorized, the IDP should also tell the zero trust platform or tell us the user's role. For example, are they part of the security team or part of the legal team? This role plays an additional definition in identifying the user and their access. Next up is the device. So how do you differentiate between a trusted and a non-trusted device? Do you have a personal or company device, and should you change the access you are granted depending on the device you're coming from? For example, you might be an authorized user, but you may be coming from a non-authorized device. So how should your access be limited? And finally is the application. And that is what is it that people are trying to connect to? And this access is based upon who the user is, the device validation, and once we have that, we also check to see if those criteria match if the application is allowed access or not. And as demonstrated on the screen here is a nice little triangle that visualizes this, because by evaluating these together, it's very simple to create secure rules and secure access control based upon these criteria. So coming back to my original diagram where we talked about connecting users to applications. So as you can probably tell, I've already talked about the idea of connecting who to what. And you might want to ask what's different between this diagram now and what was before. If I was in your shoes, I'd also be asking that question, because now we're really focusing on how do we isolate these things away. But the challenge is that enterprises don't always have the visibility. So it's easy to start somewhere if you consider the following. If you remember the who piece, this is something you probably already have a good idea about. And you can validate this by understanding perhaps the groups you have in your identity provider today. The what, of course, that is, you may not have a full understanding of the application landscape you have. Many enterprises do not. But by looking at the types of applications, maybe by broad definitions like everything in your data center, or more specifically, all of my SSH servers in AWS, then of course the question is, how do you then connect the user to those applications securely? Well, we've talked about the control mechanism, and we've built the authorization up from that. So in the scenario, just to walk through, if Jacob in legal will get access different access than perhaps Alex in security when they want to access the firewalls. So let's talk about now, we've talked about authentication. Let's consider how we connect the next phase, the cool, beautiful next step of zero trust. Now, in zero trust, it's important to understand there's a better way to look at things, and perhaps you already have that. So you don't have to, if you consider your telephone now or even your computer, if you try and access something, you don't really have to remember anything. You just basically need to open your contact list, check your inventory, or even do a quick Google search to give you the connection information path. You just then click or tap and you'll be connected directly. That's the way in which everything works today, even when you connect to a network. Well, a zero trust model actually challenges this by using a technology kind of from the past, from the early 1900s. And it's an operator-based model in that if I wanted to call Oliver, in these old days, I would have to pick up my phone and dial the operator who had a list of who was allowed to connect. Was I allowed to connect? But also knew how to connect the two parties once approved. So upon validation that I was allowed to speak to Oliver, the operator would call Oliver and ask if he wanted to talk to me, and hopefully he would. Then I would then the operator would then connect those two cables together for our conversation. Once that conversation was over, the operator would disconnect the call, and that would be the end of the call. So this is exactly what happens with the Zscaler, or with the Zscaler zero trust model we're talking about here. The user wants to access an application and calls out to the trust operator. The operator confirms that access is allowed, And as previously discussed, this is based upon the user, device, and app validation. Then the application is connected to the user through the operator. This means that the application can live anywhere, and the user can be at home, the office, the coffee shop, etc. There's no connectivity point for the user on the network. So access is enabled per user, per application, without ever connecting the user to the network, and that's critical to the way in which we think. Because if you can understand the idea of users not being connected to the network, you can start to see the use cases in which this can be utilized. Now remember that all services here are actually connecting outbound. That means everything is connecting out to that centralized operator. This means you can start using this solution, this zero trust solution, for various services, like enabling enterprises to deploy hundreds of thousands of remote access users in days rather than months, provide granular third-party access, as they only get access to what you allow and nothing more, access to multiple app hosting locations in parallel, for example, data centers and multi-cloud, connect divested or merged company user bases, granular access control to industrial control systems, or even removing the need for private access point networks. All of these services rely on the network connectivity. So what we're doing is overlaying security over the existing network, therefore not relying on the network to provide security. So going to the next diagram, and one thing you'll notice here, there's the name at the top is very important, the Private Access Protect Pro. And this is going to walk you through how this is in action, how it works in action. So here you'll see a similar image to the one we've had before, but this time around, all of the application spaces are connected outbounds to the operator, to the Zscaler cloud. And this is the little purple Zscaler app connectors, sorry, magenta, excuse me. I need to make sure I use the right naming. And this outbound connection from these locations is facilitated by that small app connector, and this establishes over a TLS tunnel to that Zscaler cloud. Well, the Zscaler cloud essentially is the operator. This connection is requested only once the user request has been validated. So if a user is not allowed access, no tunnels will be established. In this diagram, in actual fact, you can see the user is connected in parallel, not just to the data center, but also to the Amazon Web Services or Azure ecosystem all together without ever having to connect to any of those network backend infrastructure. This is solely an application-based access solution. So thus the users never get back on that network, as I've mentioned, and then we're not relying on any congestion points or any load balancers or hardware to maintain the connectivity. You're actually reducing the congestion at your data center edges. And your apps are only accessible to those people who are authorized for access. This then gives you unprecedented levels of access control without exposing your infrastructure to anyone, including the old way of having your internet gateway or your gateway exposed to the internet. And this is setting up this up is really when you walk into the scenario of giving you visibility. So one of the great things when you enable that connectivity like this is you understand what is accessed from your users and what is passing from your users to their applications. As most companies don't really have a deep understanding of exactly which application apps are running in the data center or applications, and more importantly, who's accessing them. The Zero Trust Private Access Protect Pro allows companies to perform application discovery and see who exactly is accessing those apps. Furthermore, then enforce the controls applied to those users and apps, giving you the ability not only to observe traffic like misconfigured content delivery networks or out of control software, but also find traffic paths you probably didn't even know existed. But we don't do this alone. And in fact, while Zscaler and T-Systems work together to provide the secure access path, we rely on our partners to assist, and one of those partners is Microsoft. In fact, in the end, in the end-to-end process of users accessing Zscaler services and T-System services, we integrate at many points with Microsoft. For example, authorizing users through Azure AD as the identity provider. This can include things like multi-factor authentication, Microsoft conditional access, and SCIM that all allow validation of the user and the device, along with Intune to be able to integrate to the user and device authorization. We can then leverage Microsoft Endpoint Manager to help protect the endpoint. And we can combine all the information collected here, along with the Private Access Pro traffic information, into Microsoft Azure Sentinel to allow integration and also with other security logs and deliver true security analytics. Thus, as partners, we can together deliver a great security experience to our customers. So I have talked quite a lot about how the Private Access Protect Pro service works. So allow me to walk you through the flow. Note, and please remember that this is done on a per application basis, where which we request a new set of tunnels per user per app. And the moment that those tunnels are no longer needed, we remove those. So step one here is to think about how the user requests an application. And this can be done by browsing to a file share or accessing an SQL database, any TCP or UDP session. Step two is the policy determines who's allowed access and if they are allowed access. Now, if they are allowed access, then we decide which of the app connectors, again shown here in the magenta color in the clouds, we determine which of those is the best one to service the application request for the user. Once that has been determined, we then establish the tunnels from both sides. So you can see here there's a tunnel from the user and a tunnel from the connector being connected in the Zscaler cloud near the Sydney infrastructure. I am Australian, so therefore I'm going to pick Sydney, of course. But that allows that inside-out model is controlled by that operator, that Zscaler centralized cloud. And the user, therefore, is able to connect to the application across those tunnels. And remember, this is not a permanent tunnel. This is a tunnel that is generated on a per user, per application access basis, meaning that each application has its own secure tunnel and its own secure path. Users in this case are never actually connected to a network. And because they're not connected to a network, you can understand the scenarios when we talk about connecting users to multiple applications regardless of that network path. And more importantly, there's no exposure of your applications. There's no inbound path from your users going in or from the internet going into where your applications exist. Therefore, your applications can exist in private ecosystems and never need to be shared with the outside world. So with all that being said, allow me to hand this over to Oliver to take you through how T-Systems will deliver this to you. Oliver, over to you.
Thank you, Nathan, very much. Great presentation. So now we have heard how private access actually works, the technical basis. Now let's take a look how we from TSEC are doing our deployments with our customers and what we offer during and after this process. So what you always need to keep in mind is that private access is a cloud solution. So we have quite a few steps to do before we can really integrate it in your existing infrastructure. And we as TSEC want to support our customers to do exactly that. This starts by, for example, deploying Zscaler connectors in your own data center or, for example, in a cloud environment, if it's Microsoft Azure or AWS. Also, we are doing the complete configuration of the cloud environment for our customers, including all the policies that we need. And most importantly, we support our customers to fulfill all the dependencies that we have to make it work. Nathan already said that we need an identity provider so our users can authenticate, because this is a very baseline of this product. And we want to support our customers to migrate the identity provider. Also, for example, the certificate enrollment if we want to use browser access, and even the application segmentation if our customers needs help, what user needs access to which type of applications, for example. What we also can do, but this is optional, if you want to have more visibility, we can also combine this with a CM solution, so we can send the logs to the CM and have further investigations going on. We have also some customers who are not able to configure or maintain these solutions all by themselves. So for these customers, we offer all these as single packages as a managed service. As I said, if this is necessary. So how does these services actually look like for our customers? What's really important is that we want to join these projects as soon as possible. So during the complete lifetime over a project, we as a technical expert want to join these to really inform our customers about all the requirements that we have, maybe even limitations of products. And we're not talking only about private access here. This approach is for all products and segments that the Telekom Security offers. So the technical expertise is very important during the complete project phase. If we would take a more detailed look into this, we want to start, as I said, in the consulting phase. So where we take a look on the requirements of a customer, what are the goals, what we want to achieve, and then we can search for possible solutions for these requirements. And if we found a solution that is suitable, we can design a security architecture based on this, and then start with a proof of concept. If we're talking again over private access, we can offer a proof of concept for 30 days. We also need a little bit more time in the beginning, so we can do all the dependencies. As I already mentioned, we have some, for example, the identity provider. So we prepare all these steps, and then we can start with the proof of concept so the customer really sees how this product behaves in his own environment. If the customer thinks that this is a good solution for him or a suitable solution for him, we can start with the deployment. And even we have some customers who say right in the middle of the proof of concept, okay, we think this is the right solution. Can we already jump into the deployment? This is possible as well to spare a little bit time for the implementation itself. So how does this look like, our migration roadmap? So what is the most important part is a good preparation, because a good preparation is the key to a successful deployment. The more we can define how the solution should look like, the better it is in the end. So we start by doing some workshops to really take a look what is the current situation for our customers, what are the requirements, and then we can already choose what type of identity provider do we want to use. Do we want to use multi-factor authentication or not? And by all these steps that we take during this design phase, we also create our use cases and the testing criteria so that we can later check if we achieved all the goals that we wanted to. The target of this phase is that we have a blueprint designed that we can base our further actions on. So if we jump into the next phase, in the configuration phase, we can take all the preparements that we have defined in the blueprint in the beginning, and if all this is done, so if we have an identity provider migrated, if we have the cloud configuration, and if we know what type of applications we want to connect with private access, and we have a policy design, then we can start with verifying if our blueprint works as designed. So we can start with our quality assurance right away. If everything looks good, we can proceed to the next phase. If we notice some problems, we need to adjust right here, so we doesn't carry these problems further into the deployment phase. So the last phase is a rollout. We always start with a limited circle of users and get some feedback to see if everything works stable. And if this is the case, we can enlarge the amount of users that connects over private access. So what's really important in this step is that we also include different departments, because maybe these departments have specific applications that they need to connect to that we haven't thought of in the beginning of this project, because we all know we have a lot of applications in a modern company today, and the least companies really know all applications they are using actually. So if this is all set, we can continue with the rollout until we finally reach our global migration and have adapted our blueprint, what we planned earlier. But what happens after that? So this lies within the customer's decision. So we can, for example, as I already told you, we can offer private access as a managed service. And here are some of the main benefits that we can offer. For example, or the most important is that we have a lot of experience with Zscaler products within the Telekom Security. We are doing the solutions or migrating these solutions for quite a few years now. We have seen multiple Zscaler projects and we have built our own specialized team for this. We have today we have over 60 certified Zscaler specialists within Telekom Security, and this really enables us to deliver the service quality that we want, and the service quality is according to industry standards. Also, what is very important, we have a strong partnership with Zscaler, and we're really proud of it, because if we have any problem during a rollout or afterwards, we have a short contact towards Zscaler, and they are always happy to help. So this works really good. We had a lot of great experience over the past couple of years. But enough of all the managed services and deployments. Let's take again a quick look on the use cases. Nathan already told us about them, so let's summarize it up. The main use case is of course the VPN alternative. So instead of using a classic remote access with an appliance as a gateway, we can use private access to connect our users to the applications they need. And the main benefit is that our users never have access to the general network itself. Therefore, we have an application segmentation by default and a zero trust approach. Also, what is very important, we reduce the our own attack surface, because we have no need for inbound connections in our own data center, for example, for these private applications. So no application is visible from the outside, and we have no open ports, for example, on our perimeter firewall. The next benefit is what Nathan already mentioned, is the multi-cloud access. Today, we cannot guarantee that all applications that we need are hosted within our own data centers. Maybe we have a third-party data center that we need access to, or we have a private cloud environment hosted in Azure, AWS, or whatever. We can deploy a Zscaler connector in nearly every environment. Therefore, we can connect our applications. And this also improves our user experience, because our users doesn't have to think about where the application is hosted. For the user, it just seems that he can access the application, whether he's in the internet or whether the application is hosted in the internet, in his own company network, or somewhere else. He doesn't even notice. The next key benefit is the secure third-party access. So if you have some kind of supplier who needs access to one or multiple internal applications, you can design a policy so that you really can only access these applications. And if you want, you can enroll the Zscaler application on the client from the third party, or if you have the option to that, you can also use browser access, which comes with private access. So you doesn't even need to install any kind of application. You can just enter the private applications over your browser based on certificates. So what you earn by that is that you can deliver a fast and secure third-party access, and also gain visibility into what's actually happening and who is trying to access your applications. The last benefit is we can accelerate mergers. So if you have other companies that you want to merge with, this is really easy with private access. And what's also the benefit for that, the product is really good for scalable solution. So if you notice that the bandwidth towards your applications is not big enough, you can just increase the bandwidth by increasing the amount of connectors that you have deployed. So to summarize it all up, Private Access Protect Pro is a product that can give you a lot of functionality and also can reduce the solutions that you already have in your environment. The same is for Internet Protect Pro, which is based on Zscaler Internet Access, where you can implement your secure web access with Internet Protect Pro, and therefore can also reduce the amount of solutions that you have which were responsible for this earlier. So let's take a look. If we talk about Internet Protect Pro, for example, you don't need an outbound firewall any longer. You don't need some kind of dedicated SSL inspection device. You don't need another sandbox solution. You can get all these functionalities right from the product Internet Protect Pro. And if we're talking about private access, you can reduce all the appliances and all the solutions that were before responsible for your remote access. This is not only the VPN gateway, maybe even the network firewall itself. And the only protection that you cannot replace with these products is the server protection. So if you want to offer public applications or public services over the internet from your own DMZ, for example, then you need your current infrastructure. But for example, if you want to offer a specific application only to a limited circle of users, this is exactly what you would do over private access. So that was my part. So I'm going to hand over to Dennis to wrap it up.
Well, thanks a lot, Nathan. Thanks a lot, Oliver. I think we have a clear picture now about the product, and I think the most important part is that our customers have a clear picture about the value add we will give them with our product here, together with a good service rep of Telekom Security at the end. And I think now it's clear that for every user, it's easy to access applications wherever they are and from wherever the users are, either if you are in the office, on the road, or at home. And I think also the most powerful thing here is that the technology which is behind the solution, that this is not visible for the user itself. It's just one click and their application is here. I think we got a good transparency about that, with a so easy to use and also a high security level for all applications to isolate those. And before I will pass over to Philip to answer all your questions, just a remark that we will send out the presentation after this webinar to you. And if you have further questions after this, please don't hesitate to contact us over the telephone number right here, or on the right side of our website. There is also a contact form where you can just reach out to us. And with this, I will pass over to Philip to see if we have any questions about the product. And thanks a lot.
Thank you, Dennis. As promised, I will now present your questions to the speakers. Let's see what questions came up. We have one, the private access solution. It sounds like a cloud-based VPN, am I right?
I'll take this one. That's a common question that we get, but the answer is no. It's not a VPN, because if you think about what we talked about at the beginning, VPNs are based upon networks. What the Private Access Pro is establishing secure application access at the app level, not the network level. So yes, it can be utilized like a VPN to replace VPNs to enable remote access for users. It's not built on network connectivity. It's built on application connectivity.
Okay. I think that was answered. If not, I'm going back to the question. There's another one. Am I correct that in order to make this work, I need to allow internet access to my application locations?
No. Okay. This is also a common misunderstanding. What you saw in the diagrams is not internet connections coming in to your application locations. It's where your apps, for example, your data center or your cloud locations, it's actually an internet connection going out. So in order for this to work, the app connectors need to have a connection from wherever they are out to the internet to the cloud policy engine. So that's what we're where it might be confusing is generally, if you think about it, TCP/IP has always been about, like I said at the very beginning, network-based connection. You need to have a service exposed to be able to connect to it. What we're doing here is actually turning that around and utilizing the outbound nature over a TLS tunnel from the connector to the Zscaler cloud to be able to enforce that control. So no, the answer is no, you don't need to enable internet connection into your application locations. You need to enable internet connections from your application locations to the internet, which most people probably have already.
Okay. There's one question, two more questions. Right now, how's the performance and feedback from existing customers?
That's a really good question. So the idea of performance is many things, and of course, if you like to do a comparison, it's always a fun conversation to show. I can obviously say very generally that it's the performance is much better, and that's one of the reasons why many customers choose this. But if you think about the way in which the connections are being established, it makes sense that the performance is better. Because we're not establishing a network path, we're establishing paths to individual applications. So it's based on individual sessions, and therefore we can create individual sessions to different locations. So if you think about a comparison of the old world, where you would have a VPN into a data center and then have to route across the data center to the applications, sure, that would work. But in this situation, we're talking about not going into a data center for all of the applications. We go to the data center just for one of the two applications, and then we use the cloud service directly for the other applications and so forth. So we can definitely get into the details of performance, but what we do see in the large majority of our customers is the performance is a major improvement when utilizing this, because we're breaking up the sessions, we're breaking up the connectivity into individual applications, and we're connecting each application in the most effective way. So that in itself provides greater performance than any other network-based service.
Okay, sounds good. There's one more question. What happens if part of private access fails? How do I ensure connection for my users?
Yeah, that's another good question, and I think that's actually a very valid question from any enterprise. Is how do you ensure stability of a platform? So the Zscaler platform utilized by the Private Access Pro is built upon the idea of being multi-headed, multi-threaded, and multifaceted. So each client and each connector is always consistently checking to see what is my connectivity from where I am to the Zscaler cloud. And not just one time, it's checking to say, okay, I know what my closest Zscaler cloud entity might be, and I know what the other one, I know what the next five, or the top five closest and most performant Zscaler entities might be. So for example, I'm based in Frankfurt, but I can I have connectivity from myself to the Zscaler infrastructure in Frankfurt or in Paris, probably Amsterdam, Zurich, and perhaps, I guess, just thinking geographically, it could be like Vienna or it could be London, depending on the path. So we're always looking to find that way of working, and that's a really important piece, because we're a cloud service, and like any other cloud service, we need to be available regardless of outages. So if an internet link goes down in one part of the world, can we route around that? And the idea of having multi-locations, and we have over 100 locations where we have Zscaler infrastructure, we can provide that connectivity and that stability should there be any issues, and therefore ensure that you are getting the right set of services for your end users.
Okay, sounds good to me. As far as I can see, there are no further questions, so thank you for asking them. And now I still have to thank the moderator and speakers, Dennis, Oliver, and Nathan. Thank you for this interesting webinar. And last but not least, thank you, all of you, for your interest and participation. I wish you a very nice Thursday, and stay healthy and stay tuned. Goodbye.